I don't know if my professor will be satisfied with a circle for the exam, so might as well just go all out and do 2 more cases. Uh, just to make sure I don't miss anything on that exam. So, similar to the sphere that I calculated the last part of the last video, we're gonna do an infinite wire. You see this pink, red, orange, I don't know, in your monitor screen might be a bit different, but this pink wire in my screen over here is infinite. Right? And I'm gonna calculate the electric field generated by it using the Gauss's law. So I drew this surface over here in yellow, and what do you know? We can divide this problem. Okay, let me just write just so we don't forget. Here, this EdA equals Q in over epsilon 0. And why am I writing things tilted? I don't know. Maybe because my drawing board is a bit tilted as well. But anyway, it's a bit stylish, so I kind of like it. Anyhow, we can divide this into 3 different areas: the lateral area, the right area, and the left area. So we can rewrite this as being surface integral of left of EdA plus lat EdA, right, the integral surface area, but plus the right EdA, which equals Q in, not in E0. Now, something interesting that if you have done linear algebra, or maybe not, maybe if you just know multiplication between vectors, you know that vectors that are perpendicular to each other have a product of 0. That is because we can write this as this, left EdA without the arrows, because it's no longer a product between vectors, because we're going to write cosine of pi over 2, which usually is 0. Same thing for the right one, the lateral ones not so much, so lat EdA plus blah 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 blah, right, EdA cosine pi over 2, which equals Q in E0. This is also 0, which leads us with the following equation that this must be Q in over E0, right? However, something else that you might notice is that if I take a small piece of this area over here, which is known as dA, it is pointing outwards. So is the electric field, which means that this is, I can rewrite this no longer as a vectorial product, but as E times dA cosine of 0, which equals to Q in E0, and cosine 0 is 1. So this is, and since the electrical field is a constant, we can just plug it out. Now this is a question that was on the university entrance exam for Brazil. Not this. I mean, what I'm gonna do now, which is calculating this area over here. You know, there is a lateral area, the right and left area, which we are not gonna use take into consideration because we proved that it's 0. But the area of let's say this is a toilet paper roll. So we want to calculate the area that the paper takes to enroll this cylinder. So this is just gonna be, if I open the cylinder over here, this is to R, right? Because it's the height of it, right? Or am I getting this wrong? If I open this, this is... No, sorry, I messed this up. I think it's the other way around. Yeah, I messed up a little bit. In this case, this is H, which is the length. I could call it L, but you know, H. This is H. And this is 2 pi R. Because if you open this, you're gonna see, like, if you get a scissor, cut it open, and you know, unfold it, it's just gonna be like, this is the circumference, right? Which is 2 pi R. Okay, so it's recording, thank God. So this is just gonna be H 2 pi HR. So it's gonna be E 2 pi HR equals Q in E0. So E equals to Q in over E0 times 2 pi HR. And there it is, the electrical field for an infinite wire. But you can make this even prettier, actually. You can use the sigma, the density I talked previously, which equals to Q over H, right? It's the density of that. It is H on the denominator because you can take the density of whatever size of the wire you want, because the less wire, the less charges, so the division between charge and length will be always a constant. So that's why that's the water container theorem, right? So you can just write this as being isolating a Q, so H times this equals Q. So E equals H density over E0 to pi HR, so we can cancel the R's, the H out, and it's equals to the density, or lambda. People call this lambda for some reason, but I'm gonna call it sigma, which is E0 to pi R. And that's the electric field generated by a infinitely long wire. This may get, if we're talking about a finite wire, this might be a problem because you might experience something border effect, but hopefully that won't be on the exam. So I don't gotta know this. Once again, thank you for watching.